After the classes are formed, now we need to find a way to symbolize them and make those maps show up together well with all other map features. Symbolizing classes involve choosing one symbols for each class. In this case, we have a number of choices. Because classes defined a numerical value have certain degree of high and lows, in some cases we want to show the relative high and lows across these classes. So a popular way to show that is to use a graduated symbol or graduated color as a way to show the classes progressing from low to high or high to low. In particular, we talk about how ArcGIS will be able to do this. Most of the time, graduate symbols are used to map discrete locations or features. For example, you could map the capacity of schools, the bus stops, etc. And graduate symbols show not only the location but also the magnitude of the data value in that location. We can also use the graduate line symbols to show the volumes or ranks of linear features such as road network, rivers, or utility lines. And these are common practice. However, you may also use the graduate symbol to show aggregate data on aerial pattern. For example, the graduate points can be used to show the population count in the census tract. If you figure out the central points of each census block or census tract, then it's equally powerful to use point symbols as graduate symbols. In ArcGIS, you can design the visualization of quantities by going to the Symbology tab of Layer Property and choose the categories of symbols called quantities. In that category, we have four choices: graduated color, graduated symbol, proportional symbol, and dot density. In this case, we're going to choose graduated symbol. And if you choose that type of symbology, then you have to make a number of decisions. One is the numerical field you want to symbolize. In this case, we have to choose to symbolize the population of 2009. And then you have to decide how many classes that you want to form on the value of that fields. We can show that this we have a number chosen as 7. In many cases, that's by default. You can easily change that number. The default classification scheme is natural break in this case, but you can modify that to choose other alternatives by clicking on the classify button. It will show up a separate dialog box, allows you to define which classification you want to apply to. This dialog also provides you opportunity to specify a field for normalization. The concept of normalization is the way to form a ratio number where the value field and normalization field will be divided, okay, to form the value, and that's the number that the map will show as patterns. So in this case, we can actually form values that represent either the proportion or density. ArcGIS combines the visualization and classification functions in one dialog box. Be sure to look at all the choice alternatives. Make sure that all the settings are okay with you. Proportional symbols is different way of symbolizing things compared to graduate symbol and graduate color. The two other methods basically are applying the same symbols to each class. The symbols among classes will show a graduate change. However, proportional symbols assume no classification applied to the map feature. Instead, the size of the symbol will correspond to the real value of each feature. So this case, we have a map showing the number of employees at each business. So the legends show a few samples of the size of the symbols. But in fact, if you look at the map, there's many sizes, much more sizes than the legend has. the idea is that the relative proportion size of the symbol show the proportion of the value difference. Here we show a sample dialog of designing for proportional symbols. Notice that there's no classify dialog or subpanel because it doesn't need to classify the data. What you need to do is choose the fields and choose the symbols, okay, the symbol value, and choose the number of symbols to display in the legends. This really doesn't matter that much, but what your legend will help people to get an idea of the variation. Graduate colors is very useful to symbolize the areal features that have summarized attributes, for example, population by census tracts or precipitation by the unit area. These are the kind of things that graduate color is very good at. However, when you choose the color, we make sure that you are conscious about the color who actually bring to people, because different color may mean different things. For example, red and orange tend to attract more attention and also indicating the risk, okay, the things that they need to pay attention to immediately. So if you try to map high risk area, you might want to use those warm color. But if you try to map precipitation, for example, it's probably okay to use some cool colors. Remember, the cooler colors actually can show more grade of changes than the warm colors. But in any cases, you should try to avoid showing too many classes. Normally, you can show 4 to 5 classes on the map is probably the best, but no more than 7 to 8. The graduate color can be coming from the same color or 2 different color or 3 different color. When you try to show the range of changes, if you have some kind of central value or some kind of criteria you want to apply, and there are some opposing or positive or negative sense of values around that central value, you might want to use 2 opposing colors to build a grid of colors that show things above or things below, and that will convey the idea much clearer. For example, the map on the right shows the same data as the map on the left, but use 2 different color grades to show that there's an average of 20 to 23, but others may be indicated as either below or above. If some of the decisions need to be made very differently between these 2 categories, then using 2 color grid will be very helpful. There's also a number of chart symbols in ArcGIS where you can use to symbolize either point data or area data. Using charts, you can show patterns of quantities or categories that are formed by multiple attributes in combination. We'll briefly talk about the use of pie charts and bar charts. In a pie chart, we basically divide the full circle into a few sectors, and each sector represents one attribute. So in a sense, each of the sectors are relatively independent. We would like to use colors to represent the differences. And those colors doesn't have to be same color. What you expect is to use more distinct color. For example, the pie charts on the left is less effective because it uses the same grid, which is not necessary. Instead, the pie charts on the right can read the message much better. So pie charts is similar to the proportional symbols. It doesn't apply to the classified data. It applies to the original value. So the size of each sector is proportional to the values of each feature. But the idea is if the significant difference should be able to be detected. Here we show a dialog box for designing pie chart symbol. Here what you need is to choose the chart and pie, which will automatically open up the choices. All the fields having the numerical value or quantitative values are candidates for being included in the pie charts, but you have to make sure those values included are meaningful. For example, if you have a total population and then you have numbers for the subpopulation by age, then it makes sense to include all the subpopulation into that pie, and the whole pie represents the total population. You also need to select a color scheme so that all these components are distinguishable. Be sure to be sensitive on how many fields you want to put. Don't put too many fields because it makes the pie charts harder to use. The other thing you want to be cautious is the size of the pie, because depending on the scale of the map, you may or may not have enough space to show bigger pie charts. In case that your maps is too crowded, all the pie charts are not visible, you may have to customize the pie chart size in order to make the pie chart works. You can decide to use either fixed size or variable size, and variable size means the size could vary with some attributes. Bar charts or column charts have another function to play. In some of the data sets, you may have a number of attributes that are closely related, and there's a need to compare them side by side in terms of magnitude. So the bar charts convey that message very well, but this is more like comparing features along multiple dimensions of the related attributes. The map below shows the bar chart's representation of the proportion of population by age group. So by the height of the bar charts, we can compare relative size of different groups. One of the things we can observe from this particular map is that the location of places vary by the proportion of young people and older people. Designing bar charts or column charts also do not need to classify the original data. What you need to do is to select the kind of numerical or quantitative attributes to be included in that bar chart. Then you need to choose a color scheme of those bars. You can also choose the background, but it's not that important. We recommend you to use light background if possible. You may also use some kind of normalization fields. For example, here we have a dialog use population 2009 as the normalization field. The bars are normalized by this particular total population.